In this module, we're going to get into natural language processing. So there's a few important components about natural language processing that I'm going to go through. So basically when we describe natural language processing, or NLP for short, it's basically an artificial intelligence method for communicating with intelligent systems using natural language such as English. So it's kind of just the way that a human would speak. In other words, there's a lot of devices out there like Siri, Alexa, where you can talk to it in natural language and it will understand what you're saying because it parses it using its own algorithms and does something based off of whatever you told it. Now, sometimes, of course, they don't understand and it will tell you that. It doesn't really know what you're saying, which is just a limitation of the algorithms being used and also the filtering that's used to actually clean up your voice or translate your voice into the lexicon being used by the NLP. And the field of NLP involves making computers perform useful tasks with natural languages that humans use, and the input-output of an NLP can basically be speech or written text. Of course, for things like Alexa and Siri, it's speech, but there are other forms that you're going to just type it in, and again, it's going to go through this parsing of whatever you've typed in. Now, the actual understanding of the words are not such a problem when you're typing the text because it's very clear what the words are, unless they're misspelled, of course. So let's go ahead and look at these a little bit more. So we have the components of NLP, and we get into natural language understanding, and we also have natural language generation. So natural language understanding, or NLU, basically involves a couple of tasks. We have mapping the given input in natural language into useful presentations and analyzing different aspects of the language. Now we get into also natural language generation, NLG, and this really is kind of the second component of natural language processing. So here we have text planning. It includes retrieving the relevant content from a knowledge base, so a knowledge database, for example. Sentence planning. It includes choosing required words, forming meaningful phrases, setting tone of the sentence. And textualization, it is mapping sentence plan into sentence structure. And really this is getting into all of the parsing that's going to go on whenever the algorithm, which is the component of the natural language processing that picks apart whatever it is on the input coming in to change it into instructions that will then be executed by some program. So difficulties in NLU. So NLU is more difficult than NLG. So natural language understanding is more difficult than natural language generation. And there's a few different elements that come into play. So natural language has an extremely rich form or structure. It is very ambiguous. There can be different levels of ambiguity. So if we look here at lexical ambiguity, it is at a very primitive level, such as word level, which is just super basic. And when you're at word level, you don't have the contextual component of that. So you don't have the forming of the sentence, which the words are the building blocks for the sentence, and then the forming of the paragraph, which the sentence is the building blocks of the paragraph, and then a page of content or a chapter of content, which the paragraph is the building block for there. So at the word level, there's not really much you can do with it. So for example, treating the word bored as noun or verb, which one would it be? It really has to involve a lot of contextual information around it. And we have syntax level ambiguity. So, for example, a sentence can be parsed in different ways. For example, we have, he lifted the beetle with a red cap. So what exactly does it mean? Did he use the cap to lift the beetle, or he lifted a beetle that had a red cap? Then we have referential ambiguity, referring to something using pronouns. For example, Remo went to Gary. She said, I am tired. Exactly who is tired? Then we have one input can mean different things, and many inputs can mean the same thing. So you can see here, the level of ambiguity is kind of just off the charts in what's going on with these. Then we have a set of terminology that's used in natural language processing. So there is phonology. It is the study of organizing sounds systematically. Then there is morphology, is the study of the construction of words from primitive meaningful units. And when we go back to phonology, we think about, again, Alexa and Siri and how you speak to them. That's where phonology will come in, because it's got to be able to organize those different sounds. And we have morpheme. It is the primitive unit of meaning in a language, so a basic unit of meaning. There's syntax. It refers to arranging words to make a sentence. It also involves determining the structural role of words in the sentence and in phrases. We have semantics. It is concerned with the meaning of words and how to combine words into meaningful phrases and sentences. That's really another way to say it's a context. It's a building of a context. We have pragmatics. It deals with using and understanding sentences in different situations and how the interpretation of the sentence is affected. So it's kind of another level of context as well. There's discourse. It deals with how the immediately preceding sentence can affect the interpretation of the next sentence. Another area of context. And there's world knowledge. It includes the general knowledge about the world. Now we're going to look at the steps involved in NLP. So there's going to be basically 5 of them here. And we start off with the lexical analysis. So this involves identifying and analyzing the structure of words. Lexicon of a language means the collection of words and phrases in a language. Lexical analysis is dividing the whole chunk of text into paragraphs, sentences, and words. Then we have syntactic analysis. So in other words, parsing. It involves analysis of words in the sentence for grammar and arranging words in a manner that shows the relationship among the words. The sentence such as, "The school goes to boy," is rejected by an English syntactic analyzer. So again, we kind of go back to, let's say, Siri and Alexa. The phonology part of this has played out, so the words were spoken, they are understood. We know what the words are, and we also have them in the correct order. So that's good. That's a basic piece of it. Now we have a sentence, and we need to analyze it. Is it a valid sentence? And the parser goes through with its rules and determines that. So now we get into semantic context. You can kind of think of it that way. And then moving on, we have step 4, discourse integration. So the meaning of any sentence depends upon the meaning of the sentence just before it. In addition, it also brings about the meaning of immediately succeeding sentence. Another way to build up on context. And then finally, we have pragmatic analysis. During this, what was said is reinterpreted on what it actually meant. It involves deriving those aspects of language which require real-world knowledge. Right here, we're back to semantics, of course, but we're bringing in this dictionary of various words, so the definition of various words, how they would be used, along with the rules that are involved in the parsing of the sentence, and it builds up this bigger context. So basically we have the sentence structure is valid. That's good. The definitions of the words fit into the sentence that's being used. And then finally here, we're saying, okay, all these pieces are basically valid. Now, does the whole thing even make sense? Next, what we're going to get into are the rules that can be used to take apart these sentences and parse them. Now we're going to talk about the implementation aspects of syntactic analysis. And here we really start getting into the rules of parsing a sentence. So we're going to look at context-free grammar first, and then we'll get into top-down parser. All right, so context-free grammar. It's basically a grammar that consists of rules with a single symbol on the left-hand side of the rewrite rules. We'll see what that means shortly. So we're going to create grammar to parse a sentence, and the sentence is going to be, "The bird pecks the grains." All right, so here are the different rules and how this is going to be taken apart. So articles are DET, they're the determiners, A and the, and that's just really grammar definition of articles. So then we have, of course, nouns, which here we have the plural, the singular of the various nouns. Then we have our noun phrases, the verbs, of course, and there's different versions of the verbs, then the verb phrase, and the adjectives that are being used. In this case, we don't really have any of these adjectives, but that's what they might be, for example. All right, so let's look at lexicon, and we're going to have our sentence again. So the bird pecks the grains, and if we take this apart, we use the rules that were shown earlier. We have A and the, which are articles. Adjectives, not really in this case. We have the noun, which is bird for us. We have also the verb, which is going to be pecks. Then we have something like the bird pecked the grains, which is not valid, but it can be taken apart the same way. So these are just rules that are parsing the sentence and not really creating, say, a correct context. So this is just one component. Other components are needed to make it valid. All right, so now we're going to look at the top-down parser. And that is really more involved. There's quite a bit to it. So with the top-down parser, it starts with the symbol S and attempts to rewrite it into a sequence of terminal symbols that matches the classes of the words in the input sentence until it consists entirely of terminal symbols. So you can see there quite a bit going on. Now all of that is then checked with the input sentence to see if it matched. If not, the process is started over again with a different set of rules. So this is repeated until a specific rule is found, which describes the structure of the sentence. And so the advantages of this is that it's simple to implement. So some disadvantages might be it is inefficient as the search process has to be repeated if any errors occur, which can, of course, slow the speed of all of that working. So if we look at context-free grammar, the advantages there are simplistic style of grammar, therefore it's widely used. But some of the disadvantages are not highly precise. For example, the grains pecked the birds, so the sentence that we were using is syntactically incorrect according to the parser. But even if it makes no sense, the parser takes it as a correct sentence. So we saw that in one case, it looked good. Then we brought the sentence up again. We saw how pecks and peck kind of fall into the same verb part of the rule. So that kind of completes our overview of a little bit of theory. As we're getting into natural language processing, we're going to go ahead and move into some more application by getting into the code.